Most people think the space race started in 1957 with Sputnik. Some say it ended in 1969 with the moon landing. But in June 1944, before the end of World War II, a German rocket crossed the edge of space. Not a satellite, not a capsule, a weapon. It flew faster than sound, higher than any machine before it, and proved spaceflight was possible 15 years early. Its designer was Wernher von Braun, and at the time, Hitler thought he was wasting money. After World War I, Germany was stripped of its weapons. The Treaty of Versailles banned heavy artillery, crushed the army down to 100,000 men, and left generals humiliated and cornered. But one thing was never mentioned: rockets. Inside the German army, a dangerous idea began circulating. If they could not build cannons, could they build something that flew instead? In 1932, Captain Walter Dornberger was told to investigate rockets. Most officers laughed it off. Rockets were circus toys. But Dornberger found someone who did not laugh: a 20-year-old student named Wernher von Braun. Von Braun was obsessed. He was not trying to win wars, he was trying to leave Earth. As a teenager, he stared through a telescope and read Hermann Oberth late into the night. He failed maths until he realized equations were the only way to reach space. Now the army was offering him funding, facilities, and freedom. Not to explore the stars, but to build weapons. The problem was simple. Rockets were a joke. Across Germany, amateur clubs launched devices that barely cleared trees. In America, Robert Goddard had reached a few kilometers at best. Von Braun's early tests were no better. Most exploded. Some never left the ground. Every failure made the skeptics louder. By 1937, the army moved von Braun's team to Peenemünde, a massive base on the Baltic coast. Hundreds of engineers, vast budgets, endless pressure, and still nothing worked. Rockets detonated on launch. Engines tore themselves apart. Fuel systems failed. Each explosion reinforced the same conclusion inside Berlin. This was a fantasy project led by a dreamer. Then the war began. In September 1939, Adolf Hitler made his decision. The rocket program was downgraded to the lowest priority. Resources were pulled, engineers reassigned. The message was clear: if rockets did not work soon, they would never work at all. Von Braun was running out of time, money, and political protection. One more failure could end the program forever. Von Braun had promised Dornberger a weapon, but first he had to teach a 13-ton missile how to fly straight. December 1937. Greifswalder Oy, a small island in the Baltic. Von Braun stood on the frozen beach, hands shoved deep in his coat pockets, watching his fourth A3 rocket on the launch stand. The engine ignited with a roar that echoed across the water. The rocket lifted, climbing steadily into the grey winter sky. Then the parachute deployed too early, ripping open in the exhaust stream like paper in a hurricane. The rocket tumbled end over end before crashing into the sea. Von Braun didn't move. 3 earlier launches that week had ended the same way. Engines cutting out mid-flight, guidance systems failing, rockets spiralling into the Baltic. 4 launches, 4 failures. As he walked back to the boat, boots crunching on the frozen sand, one thought circled in his mind. The engine works, but without guidance, all that power is useless. The propulsion problem alone seemed impossible. Robert Goddard in America used pressure-fed rockets. Compressed gas pushed fuel into the combustion chamber. Simple, reliable, but weak. Goddard's best engine produced 985 pounds of thrust. The German army needed 60,000. Therefore, von Braun needed turbopumps. His team designed a steam turbine spinning at 5,000 revolutions per minute, driving centrifugal pumps that forced 125 litres of fuel per second into the combustion chamber. The steam came from mixing hydrogen peroxide with sodium permanganate, a chemical reaction violent enough to produce 600 horsepower. But turbopumps spinning that fast could explode. If they spun too fast, the pumps tore themselves apart. If they spun too slow, the combustion chamber starved and melted. Every component had to be balanced to the width of a human hair. But then came the guidance problem. Von Braun's team built gyroscopes. One sensed pitch, another monitored yaw and roll. The gyroscopes could detect when the rocket tilted, but signals took time to process. By the time the control surfaces responded, the rocket had already tumbled. Therefore, they needed an analog computer, the Mischgerät, to calculate corrections in milliseconds. But the computer needed power. Therefore, they added a 24-volt electrical system with generators driven by the turbopump. The computer sent signals to 8 control surfaces, 4 external rudders on the tail fins, 4 graphite vanes positioned directly in the rocket's exhaust stream. The vanes sat in temperatures of 2,500 degrees Celsius. Only graphite could survive. But if any single component failed, the gyroscope, the computer, the electrical system, the vanes, the rocket became a 13-ton spinning bomb. June 13th, 1942. Peenemünde Test Stand 7. Field Marshal Wilhelm Keitel and General Alfred Jodl stood behind sandbags, arms crossed, watching the first full-scale A4 prototype. This was the demonstration that would decide the program's fate. Von Braun stood near the control bunker, mentally running through every calculation one last time. His palms were sweating, despite the cold morning air. The math was perfect, he thought, but math doesn't explode. Hardware does. The countdown began. The engine ignited with a deafening roar. The rocket lifted 3 meters off the pad. Then it exploded. A fireball engulfed the test stand, sending a shockwave across the facility. Officials dove for cover as shrapnel tore through the observation bunker. Von Braun, standing near the pad, hit the ground as twisted metal screamed past his head. When the smoke cleared, he stood slowly, staring at what remained. Twisted metal, charred concrete. Nothing else. The engine had produced 60,000 pounds of thrust, but the structure couldn't handle it. Therefore, the rocket tore itself apart. The generals walked away in silence. Von Braun knew he had weeks, maybe days, before Hitler shut them down. 2 months later, August 16th, 1942, they tried again. Structural reinforcements had been added throughout the airframe. The second A4 sat on the pad, its skin gleaming in the summer sun. The engine ignited. This time, the rocket lifted cleanly, rising faster and faster into the sky. It climbed, it accelerated, it reached altitude. Then, it disintegrated. Von Braun watched through binoculars as pieces tumbled from the sky like confetti. The structure held. The engine worked. The guidance was stable. So what happened? His engineers scrambled for answers, poring over telemetry data. The problem was aerodynamics. No one had built a wind tunnel that could test speeds above Mach 1. They were flying blind into unknown territory. The investigation revealed the truth. The rocket reached Mach 4 during ascent, but during re-entry, friction heated the thin steel skin to 600 degrees Celsius. Panels buckled and ripped open. Superheated air flooded in, causing structural failure. Von Braun stared at the wreckage scattered across the impact zone. We'd solved thrust, he thought. We'd solved guidance. Now the air itself is trying to kill us. The solution was reinforcement. Riveted bands around the forward section to prevent buckling. But adding weight reduced range. Every gram of reinforcement was a meter of range lost. Make it too strong, and the rocket couldn't reach the target. Make it too light, and it would disintegrate. Therefore, they designed the rocket body based on a rifle bullet, a shape known to be stable at supersonic speeds. They added oversized fins. They conducted wind tunnel tests at Peenemünde, pushing their equipment to Mach 5, the absolute limit of what they could measure. But there were no guarantees. They were still guessing. But then there was the combustion chamber. Inside, fuel and liquid oxygen mixed at 15 bar pressure, creating temperatures of 2,500 degrees Celsius. But steel melts at 1,500 degrees. Von Braun's first attempt was thicker chamber walls, but the rocket was too heavy to lift off. His second attempt was different metal alloys, but they still melted under sustained burn. Therefore, he designed a double wall structure. Alcohol fuel flowed through the gap between the inner and outer walls before entering the combustion chamber. The fuel absorbed heat from the walls, cooling them, while simultaneously preheating itself for more efficient combustion. But if too much fuel entered the gap, pressure could cause a catastrophic explosion. Therefore, they added a relief valve that would vent excess pressure before the chamber ruptured. Von Braun stood in the workshop one night, staring at the chamber assembly under the harsh fluorescent lights. "We're asking a metal box to contain the temperature of the sun," he thought, while flying at 5 times the speed of sound. And it has to work for 65 seconds without failing once. By late 1941, von Braun had solved each problem on paper. Turbopumps, gyroscopes, reinforcement, cooling. But paper doesn't explode. Paper doesn't tumble. Paper doesn't kill generals watching from observation bunkers. He needed one perfect test. One flight that didn't end in fire and twisted metal. But Hitler had already written him off as a dreamer, wasting the Reich's money. Time was running out. Then, in March 1944, just as the A4 was finally showing promise, von Braun's world collapsed. SS officers arrived at Peenemünde in the middle of the night. They arrested him on charges of undermining the war effort. The evidence? An overheard conversation at a party where von Braun, after too much wine, had said he was more interested in space travel than building weapons. The Gestapo had a file on him. They claimed he had a plane at Peenemünde with which he could fly to England with the A4 secrets. Von Braun spent 2 weeks in Gestapo custody. The charges were absurd, but in Nazi Germany, absurd charges could end with a firing squad. He later said the accusation was taken quite seriously, treason against the Reich. But the real purpose wasn't justice, it was control. Heinrich Himmler, head of the SS, wanted to wrest the A4 program away from the army and place it under SS command. Von Braun was leverage. Major Dornberger, however, would not let his chief engineer be sacrificed. After 2 weeks, he interrupted the proceedings with an order directly from the Führer to release von Braun on parole. He and Albert Speer, Berlin's war production chief and arch-enemy of Himmler, had convinced Hitler that von Braun was too important to the rocket program. Von Braun was released. His probation was quickly forgotten by everyone except the man who had imprisoned him in the first place. But something had changed. Von Braun had directly experienced how a dictatorship worked when one started to disagree with the leadership. His feelings toward the Third Reich were forever altered. He returned to work, but now he understood the stakes weren't just technical, they were personal. But in a cluttered workshop at Peenemünde, surrounded by broken prototypes and crumpled blueprints, von Braun rolled up his sleeves and got back to work. He had a stubborn belief that the impossible was just a problem no one had solved yet, and he was about to prove them all wrong. Von Braun had one last chance to prove Hitler wrong. October 3rd, 1942. The third A4 prototype sat on Test Stand 7 at Peenemünde. His hands gripped the edge of the control console. This is it, he thought. 2 explosions, 2 failures. Hitler's patience is exhausted. If this rocket doesn't fly, the program is finished. The engineers had made changes after the August disaster. They reinforced the structure, they adjusted the guidance system, they recalculated the aerodynamics. But there were no guarantees. They were still flying blind above Mach 1. 1 degree off in guidance meant miles off target. 1 weak weld meant explosion. 1 gyroscope malfunction meant tumbling into the Baltic. Von Braun watched the technicians run final checks. We've fixed everything we know is broken, he thought, but what about what we don't know? The countdown began. Engineers fell silent, eyes fixed on gauges. Von Braun's jaw clenched tight enough to ache, but his hands remained steady on the console. Ignition. The engine roared to life, with a sound that shook the concrete beneath their feet. Steam vented from the test stand. The rocket lifted, slowly at first, then faster. The structure held. The guidance held. If it was going to explode, it would happen now. But it didn't. The rocket kept climbing, accelerating, punching through the sound barrier with a crack that echoed across the Baltic. Then it disappeared into the clouds. For 30 seconds they had no visual, only telemetry. The radio crackled, velocity increasing, altitude climbing, guidance stable. The numbers kept coming. 50 kilometers, 60, 70, 85 kilometers altitude, 190 kilometers downrange. The rocket had worked. The observation platform erupted. Engineers embraced, shouting, crying. Some fell to their knees. Von Braun stood motionless for a moment, letting it sink in. Then he smiled. That evening he gathered the team. Champagne appeared from somewhere. Major Dornberger raised his glass. "We have invaded space with our rocket for the first time," he said. "This is the first of a new era of transportation, that of space travel." The room fell silent. They had built a weapon. But in that moment, they saw something else. A path to the stars. Someone toasted Hermann Oberth, the visionary whose theories had inspired them all. The conversation turned to space stations, to orbiting the Earth, to possibilities that seemed impossible just hours before. Von Braun stood quietly, glass in hand. Today we built a weapon, he thought, but we also built something that can reach the stars. The film of the launch was sent to Hitler's headquarters. For weeks there was silence. Then, on December 22nd, 1942, the order came. Hitler had watched the footage. He sat, deeply stirred, unable to speak. Then he leaped up. "This will be the decisive weapon of the war," he declared. Mass production was authorized immediately. The program was given the highest priority, equal to panzer production. Whatever labor, materials, or funding von Braun needed would be supplied instantly. The man who had called von Braun a dreamer, wasting the Reich's money, now couldn't stop talking about rockets. But success bred demands. Mass production required a factory, a massive factory, one that could produce thousands of rockets while protected from Allied bombing raids. The answer was Mittelwerk, an underground complex carved into the Harz Mountains. 2 parallel tunnels, each a mile long, connected by 46 cross tunnels. The rockets would be assembled deep beneath the earth, safe from RAF bombers. But building the factory and producing the rockets required labour, thousands of workers. In wartime Germany, that meant prisoners. Von Braun visited Mittelwerk multiple times to inspect production. The conditions were worse than any mine. The air was thick with rock dust and the acrid smell of chemicals, a poisonous mixture that filled the lungs of workers as they laboured for up to 18 hours a day. Prisoners, emaciated and hollow-eyed, assembled rocket components under the watch of SS guards. They slept in the tunnels they dug. Their only toilets were oil barrels cut in half with boards over them. The stench was intolerable. Starvation and poor hygiene led to outbreaks of typhoid and tuberculosis. Those accused of sabotaging production were hanged from cranes above the assembly lines as a warning to others. Von Braun saw this. He walked through those tunnels. He saw the prisoners. He saw their condition. Years later, he would claim he had no choice, that he was unaware of the worst abuses. But survivors remembered differently. They recalled seeing him inspecting the production lines, watching as skeletal workers assembled his rockets. One survivor, Hans Kammler, reported overhearing von Braun say to a colleague, "That's how it is with these Poles and Russians. Every week we get new ones." Whether he actively encouraged the brutality or simply accepted it as necessary, the result was the same. By the time the war ended, approximately 20,000 prisoners had died building the V-2. More people died making the rocket than were killed by it. But von Braun's childhood dream was about to be realized. June 20th, 1944, Peenemünde. Von Braun stood in the control room as a V-2 was prepared for a purely vertical launch. No target, no warhead, just altitude. The rocket climbed straight up, higher than any previous test. Telemetry readings scrolled across the console. 100 kilometers, past the edge of the atmosphere. 150 kilometers. 176 kilometers. Von Braun watched the numbers climb, barely breathing. "Since I was 13, staring through my telescope, I dreamed of this," he thought. The rocket that would soon terrorize London had just become humanity's first spacecraft. This happened 3 months before the first V-2 was fired in combat. By September 1944, mass production at Mittelwerk was complete. Mobile launch units were deployed across occupied Europe. On September 8th, 1944, the first V-2 struck London. Chiswick, a residential neighbourhood. The rocket arrived without warning. It travelled at Mach 4, faster than sound. There were no air raid sirens, no time to take cover. The first thing people heard was the explosion, then the roar of the rocket that had already hit. Over the next 7 months, more than 3,000 V-2s were launched in combat. They struck London, Antwerp, Liège, and other Allied cities. Each one travelled faster than any defence could intercept. Approximately 9,000 people were killed by V-2 strikes. But they came too late to change the war. The Allies were already advancing across Europe. The factories were being overrun. Von Braun would later say he felt deep regret for the victims of the V-2, but he also said, "War is a war, and when my country is at war, my duty is to help win that war." The moral calculus was complicated. He had built a revolutionary machine. He had reached space. He had also built a weapon of terror funded by slave labour. The cost was incalculable. As Germany collapsed in early 1945, American and Soviet forces raced toward Peenemünde. Both sides understood what von Braun had built. It wasn't just a weapon, it was the key to the future. Whoever captured the rockets, the engineers, and the technical documents would control the next era of warfare and exploration. Von Braun, facing capture, made a calculated decision. He gathered his team and loaded 14 tons of technical drawings, blueprints, and V-2 scientific data into trucks. They hid the documents in an abandoned mine in the Harz Mountains, a bargaining chip for the future. He knew the Americans would value his knowledge more than the Soviets would. He preferred American capitalism to Soviet communism, and he understood that his expertise could buy him a new life far from the ruins of the Third Reich. Von Braun and his team fled south, away from the advancing Soviet forces, toward American-occupied territory. They had made their choice. On May 2nd, 1945, von Braun sent his younger brother Magnus ahead on a bicycle to make first contact with American troops in the Austrian Alps. Magnus approached a patrol from the 44th Infantry Division. "My name is Magnus von Braun," he said in broken English. "My brother is Wernher von Braun. He invented the V-2 rocket. We wish to surrender to the Americans." The soldiers looked at each other, confused. The name meant nothing to them. But Magnus insisted they radio their superiors. Within hours, word reached US Army intelligence, and they were ecstatic. Wernher von Braun was at the top of their most wanted list. Von Braun surrendered, along with over 100 of his colleagues. His left arm was still in a cast from a car accident weeks earlier. He stood calmly as American officers questioned him, already thinking about the future. He had the rockets. He had the documents. He had the knowledge. And now he had the Americans' attention. Operation Paperclip was about to begin. The rocket designed to destroy London would eventually take humans to the moon, and the man who built it would not face trial. He would be recruited. The question was no longer about guilt or innocence. The question was, who would control the future of rocketry? Von Braun had just made sure it would be the Americans. The transformation happened faster than anyone expected. One moment, an SS officer overseeing slave labor in underground tunnels. The next, standing in the Texas desert heat, teaching American soldiers how to build rockets. Fort Bliss, 1945. Von Braun watched as captured V-2 parts were unloaded from railway cars, wiping sweat from his brow in the unfamiliar sun. An American officer approached. "Show us how it works, Doc." Von Braun nodded. 6 months had changed everything. Operation Paperclip brought over 120 German scientists to the United States. Their Nazi pasts were scrubbed from official records. SS ranks disappeared. War crimes allegations vanished. Their families would join them later. The US government had made a calculated decision. Technological superiority mattered more than moral accountability. Von Braun was among the first to arrive, and he quickly became the most valuable. He had the knowledge, he had the vision, and he had no intention of looking back. At White Sands Proving Ground in New Mexico, American engineers under von Braun's guidance began reassembling captured V-2s. Between 1946 and 1952, approximately 80 V-2s lifted off from the desert. They no longer carried warheads, but scientific instruments, cosmic ray detectors, atmospheric sensors, cameras. On October 24, 1946, a V-2 carried a 35mm camera to 65 miles altitude. When the film canister was recovered from the crashed rocket, scientists crowded around to see the developed images. The first photographs of Earth from space. Grainy black and white pictures showing the curvature of the planet against the blackness beyond. The weapon that had terrorized London was now photographing Earth from space. In 1950, von Braun and his team were transferred to Redstone Arsenal in Huntsville, Alabama. He became technical director of the Army Ballistic Missile Agency. They designed the Redstone missile, a direct descendant of the V-2. It used the same principles: liquid oxygen and alcohol propellants, turbopump fuel delivery, gyroscopic guidance. But it was more reliable, more accurate, and more powerful. Von Braun was no longer just copying German technology. He was improving it. But von Braun understood something his colleagues didn't. Technical excellence wasn't enough. He needed public support. In 1952, Collier's magazine published a series of articles on space travel with von Braun as technical consultant. The brilliant illustrations by Chesley Bonestell captured the public imagination. Then came Disney. Between 1955 and 1957, von Braun appeared in 3 Disney television specials: Man in Space, Man in the Moon, and Mars and Beyond. He explained rocket science to millions of Americans in their living rooms. His German accent, once a liability, became charming. His enthusiasm was infectious. The former Nazi became a household name, the trusted face of America's space future. In 1955, he officially became a US citizen, renouncing his German citizenship. The transformation from SS officer to American space pioneer was complete. Then came October 4th, 1957. The Soviet Union launched Sputnik 1, the world's first artificial satellite. America was shocked. The Sputnik crisis gripped the nation. If the Soviets could put a satellite in orbit, they could put a nuclear warhead anywhere in America. Von Braun was furious. "We could have done it 2 years ago with our Redstone," he told reporters. He was right. The Army had a satellite ready, but President Eisenhower had chosen the Navy's Vanguard program instead, wanting a civilian rocket rather than a military one. On December 6, 1957, the nation watched as Vanguard TV-3 was prepared for launch at Cape Canaveral. The rocket ignited, rose 4 feet, and exploded on the pad. Newspapers called it Flopnik and Kaputnik. It was a national humiliation. Finally, the Army was given permission. Von Braun's team had 90 days to launch America's first satellite. January 31st, 1958, Washington, D.C. A late-night press conference. Von Braun, James Van Allen, and William Pickering held up a model of Explorer 1 above their heads. The satellite was in orbit. America had answered the Soviets. Von Braun's smile was genuine for the first time in years. Reporters shouted questions, cameras flashed. The former Nazi rocket scientist had just become an American hero overnight. The man who built Hitler's vengeance weapon had saved America's pride. In 1958, President Eisenhower created NASA, a civilian space agency. Von Braun lobbied hard to be part of it. In 1960, he became director of the newly established Marshall Space Flight Center in Huntsville. For the first time in 26 years, he was not designing weapons, he was designing spacecraft. His team began work on the Saturn family of rockets. The Saturn V would become his masterpiece. Standing 363 feet tall, it was 8 times taller than the V-2. Its first stage engines produced 1.5 million pounds of thrust each, 30 times more powerful than the V-2. It was the most powerful machine ever built. On May 25, 1961, President John F. Kennedy stood before Congress and declared, "I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth." Von Braun had been waiting his entire life for this moment. A clear goal, unlimited funding, national priority, everything he needed to fulfill his childhood dream. July 16th, 1969, Kennedy Space Center. Von Braun stood in mission control, watching monitors as the Saturn V ignited. The ground shook. The rocket lifted, slowly at first, then faster, climbing into the Florida sky. It performed flawlessly. 4 days later, on July 20th, Neil Armstrong stepped onto the lunar surface. Von Braun's eyes were wet, but he didn't wipe them away. The boy who stared through a telescope at age 13, dreaming of reaching the moon, had just made it happen. The V-2 designer had taken humanity to the stars. The Saturn V never failed in any of its missions. It was, by every measure, a triumph. But the triumph came with uncomfortable questions. How did a Nazi SS officer become an American hero? Was Operation Paperclip morally justified? Did the ends, the moon landing, satellite communications, GPS, weather forecasting, justify the means? The whitewashing of war crimes? The deliberate forgetting of 20,000 dead prisoners? In 1984, 7 years after von Braun's death, these questions resurfaced. Arthur Rudolph, von Braun's colleague and the V-2's chief engineer, was investigated by the Office of Special Investigations. Evidence emerged of his complicity in the slave labour at Mittelwerk. Rather than face prosecution, Rudolph renounced his US citizenship and returned to Germany. He had worked at NASA. He had helped design the Saturn V. He had retired in 1969 as a respected engineer, but the past had finally caught up with him. Von Braun died before similar scrutiny could reach him. Throughout his life, von Braun maintained his defence. "I was interested in space, not politics," he said. He claimed he had no choice but to join the SS. He insisted he was unaware of the worst abuses at Mittelwerk. "War is war," he said. "When my country is at war, my duty is to help win that war." But survivors of Mittelwerk remember differently. They saw him in the tunnels. They watched him inspect production lines. They heard him make callous remarks about prisoners. He saw us, one survivor said. He knew. The evidence suggests von Braun knew exactly what was happening. He saw the conditions. He accepted them as necessary. He chose his rockets over their lives. The moral calculus is brutal. 20,000 prisoners died building the V-2. 9,000 people were killed by the weapon. But von Braun's work also took 12 humans to the moon. It enabled satellite communications that connect the world, GPS systems that guide billions, weather forecasting that saves lives, Earth observation that monitors climate change. Does the good outweigh the evil? There is no easy answer. History doesn't offer clean verdicts. It offers consequences. In 1970, von Braun left Huntsville for Washington, D.C., becoming NASA's Deputy Associate Administrator for Strategic Planning. In 1972, he left NASA entirely to join Fairchild Industries as Vice President. In 1973, he was diagnosed with kidney cancer. Surgery removed the tumor, but the cancer returned. In 1975, President Gerald Ford awarded him the National Medal of Science, the highest scientific honor in America. Von Braun was too ill to attend the ceremony. On June 16, 1977, Wernher von Braun died in Alexandria, Virginia. He was 65 years old. He was buried at Ivy Hill Cemetery. His epitaph, chosen by him, reads simply, Psalm 19:1. The heavens declare the glory of God, and the firmament showeth his handiwork. Today, every rocket launch, SpaceX's Falcon 9, NASA's Space Launch System, Russia's Soyuz, uses principles von Braun pioneered. Turbopump propulsion, gyroscopic guidance, regenerative cooling. The mechanics are refined, computerized, scaled to unimaginable power. But the logic is identical. We live in a world shaped by the V-2. Every satellite orbiting Earth, every GPS signal guiding a car, every weather forecast predicting storms, every communication relay connecting continents, all depend on rockets that trace their lineage to Peenemünde. The same technology that created intercontinental ballistic missiles also created the International Space Station. Von Braun's legacy is uncomfortable. His rocket was built by slave labor. 20,000 prisoners died in the Mittelwerk tunnels. 9,000 civilians were killed by V-2 strikes. Yet, the same rocket opened space to humanity. The question haunts history. Was the cost worth it? Can those deaths be justified by moon landings and satellite communications? History doesn't offer clean answers. It offers consequences. The artillery officer who Hitler called a dreamer had built the first spacecraft, and in doing so, he had given humanity a choice: reach for the stars or aim at each other. 80 years later, we're still making that choice. Every time a rocket lifts off, carrying satellites or warheads, exploration or destruction, we see the dual legacy of Wernher von Braun. The rocket doesn't decide. We do.